Okay.
So we have Russ Lord here. He's going to explain his exhibit.
Okay, well, I was on the UltraSPARC design team at Sun Microsystems back in the 90s. And so I hooked up with Paul. He's got all the workstations. He introduced me to this convention. And I said, well, I want to go at least. So first 2 years I visited. And now this year I'm exhibiting. And so I've got the processors from UltraSPARC 1 through UltraSPARC T2, which of course became an Oracle chip, sadly. And I have a couple of active displays. This is the actual chip that I decapped. You can move around and kind of see different parts of the logic and see what it looks like. Some interesting features like there's some memory, maybe a cache and stuff like that. And then this is the actual die of that decap. This is the ball grid array. This is the part that gets soldered onto the board. And then I pop that cap off, boom, and there's the die. And that's what I'm displaying here. So this is the UltraSPARC 2. Other processors I haven't decapped yet. This is an UltraSPARC 3. This, I've decapped the 4. Unfortunately, the die's on the bottom side, so there's no electronics on this side. This is just the substrate. And so I didn't want to risk this chip by taking it off. If I crack it, I got nothing to show. But
No pun intended, risk this risk.
You know, I'm going to use that the whole rest of the weekend. And that's what it looks like if you could find that. And I have, of course, the poster of it also. And so I have various processors. This is what started the whole SPARC thing. My mentor, Dave Patterson, okay, he proposed the Berkeley RISC. We worked on the Berkeley RISC. That became, I have a progression chart, but anyway, the Berkeley RISC 1 was in-house, we did. The Berkeley in silicon, the Berkeley RISC 2 we did on campus, made the chip, and that became the SPARC processor, Sun's first design. Before that, they used 68Ks. And that became the SPARC, and then we did the UltraSPARC. That's when I joined Sun. I didn't join Sun until the UltraSPARC. And so this was the seminal paper that Patterson published out of Cal about RISC architecture. IBM had proposed RISC, played with it for maybe 8 years, but this is the only one that really got implemented. It showed that some students could actually make a chip that was a processor, and that made the market open. People said, well, they can do it, I can do it. Stanford did their MIPS project. Both the Stanford MIPS and the Berkeley RISC were DARPA funded. And so the military complex paid off because we have all these processors. And the Berkeley RISC 2 became the SPARC. And so what I'm showing here are a few physical samples. I have some of the dies, what they look like inside. Some of the photos have the different logic components of it. And then this final display shows an implementation of the UltraSPARC T2, which Sun Oracle released as an actual chip, processor chip. And then they opened up the code for the T1 and T2 and put it on the internet. All the code, the specifications and everything.
Is that what this is right here?
And this is the T2 implemented in a Xilinx device. And I can't fit 8 processors, all the memory controllers and all that stuff on it. So what I have is 2 execution units. You can see here, 2 execution units. I've got a crossbar switch, which is on the chip, of course, and 2 of the 3 memory harnesses. And then I've highlighted various parts of the chip in the Xilinx. And people might think that the processor, oh, that must be the biggest part of the chip. And you go like, no, it's RISC, reduced. It's small, it's tight, it's fast. It's actually, that's one of the units right there. And it's that color. And that's all it is on the chip. That's where it's located, that's the size of it and all. I could, if I want, let's see what the other processor looks like. So I can highlight that, and let's make it like this bright blue and see where it pops up there. Now you can see it popped up there. So those are the 2 processors on the chip. The big part, what is that? What could be that big if those are if those are the processors? It's called the FGU, and that's the floating point and graphics unit. And then, okay, that might make sense. A, it's a floating point and graphics unit. B, it's shared between all the processors.
And
So
you said that's the FGU?
FGU, floating point, and there's various parts here of what their process is. So that makes sense. That might be a big chunk of it.
So I'm assuming the UltraSPARC was a lot stronger in floating point than integer compared to Intel.
Oh yeah, yeah, sure. Yeah, it was built for it, but it was also built for execution speed of instructions. Very tight. The whole RISC architecture took the theory that rather than have big, complicated instructions that one instruction can do everything, it went to the theory, well, let's make small, tight instruction set that runs very, very fast, very economical in size on chip and speed, and it might take 5 instructions to do what one Intel chip takes 1 instruction. But if it's running 10 times faster, we've saved time. And it's running that much faster, and that proved out. And that's why RISC is, and because of its size, ARM, which is also a RISC architecture, ARM became popular, and it's in almost everything, the ARM processors. But now with AI, the same guy, Dave Patterson, that proposed Berkeley RISC, proposed in 2014 the RISC-V, and that's becoming the de facto standard for AI. And so both times he was kind of had it right. This one, the Berkeley RISC got taken over by ARM, but it's still the same basic principle, a little expansion on the registers and whatever.
If you don't want me asking one last question before I end this interview,
Yeah.
what was your dissertation in?
I can't talk about that.
Okay.
Because it's DoD classified.
Never mind then.
Edit that out. I was just talking to some people, a young couple, and they're working for SpaceX Starlink, and they're like in the same boat. I told them my story, and I said, but I can't tell you what, even my kids. And she said, my dad, he was doing the same thing. The gal said, the same thing. He can't talk about what he did. I don't even know what he did because he can't talk. And I can't sort out what's declassified. Maybe I could talk about, and what's. I mean, I remember what.
Hold on a sec.